Assalamu alaikum warahmatullahi wabarakatuh. Dear students, today we will study the most important theorem in the chapter triangle, that is perpendicular bisector theorem. So let us see the statement of the theorem. The statement of the theorem is every point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. So let us consider segment AB and line L is a perpendicular bisector of segment AB, which is given, that is this line is perpendicular bisector of segment AB at point M, that is here segment AM is congruent to segment MB. This is given. We have to prove that PA, any point you take, let us take a point P. So this PA is congruent to PB. We have to prove. So draw join AP and PB. This is the construction. Construction part is draw segment AP and segment BP. Theorem. So let us consider triangle APM in triangle APM and triangle BPM. Triangle BPM. In this both the triangles, segment PM is in triangle APM as well as in triangle BPM. So segment PM is congruent to segment PM, common side. Segment PM is congruent to segment PM, common side. Angle PMA, angle PMA is 90 degree is equal to angle PMB. This is also this is the perpendicular bisector. So perpendicular bisector makes angle 90 degree to the segment AB. So angle PMA is congruent to angle PMB. PMA is congruent to angle PMB, each 90 degree. Each angle is right angle, each 90 degree. Now segment M is congruent to segment BM. It is given, since M is a midpoint, so segment AM is congruent to segment BM, which is given. Therefore triangle APM is congruent to triangle BPM by side included angle and side test. Side angle, side test of congruence, they are congruent. Therefore its corresponding sides are congruent once the triangles are congruent. Therefore segment PA is congruent to segment PB, that is corresponding side of congruent triangle, that is PA is equal to PB. This we have proved the theorem. Part 2 of perpendicular bisector theorem. Statement of the theorem is any point equidistant from the endpoints of the segment lies on perpendicular bisector of the segment. So given part is, let point P be any point equidistant from the end point of the segment AB. So AB is the segment, let point P be equidistant, means PA and PB are equal. This is given. PA is equal to PB. P is equidistant from end points of the segment AB. Now we have to prove that this point P is on perpendicular bisector of segment AB. We have to prove it. So to prove this theorem, take a midpoint M. You have to take one midpoint, like that is AM and MB are equal. You have to take midpoint and draw segment PM. So segment AM is equal to segment BM. This is the construction. Now we'll consider two triangle proof of the theorem. In triangle PAM and triangle PBM. In triangle PAM and triangle PBM. These two triangles, segment PA is congruent to segment PB, which is given. Then segment AM is congruent to segment BM. Construction, we have done the construction that it is considered the midpoint. So by construction, this AM is congruent to BM. Third thing, this PM is common side in both the triangles. In triangle PAM as well as triangle PBM. PM, segment PM is congruent to segment PM. It is a common side. Therefore, triangle PAM is congruent to triangle PBM by side test. All three sides of one triangle are congruent to corresponding all three sides of another triangle. So these two triangles are congruent by side test. Therefore, angle PMA is congruent to angle PMB. PMB corresponding angle of congruent triangle. Now this angle PMA and angle PMB are on the straight line AB. So their angles in linear pair. So sum of the angles in linear pair is 180 degree. So now angle PMA plus angle PMB is equal to 180 degree. Angles in linear pair. Straight line, angles in linear pair. Sum of the angles in linear pair is 180 degree. But PAM is equal to PBM. So give your number 1. So angle PAM, this PMB is equal to PMA. So here PMA and PMB are equal. From 1 is equal to 180 from first. Now therefore here angle PMA plus angle PMA and 2 angle PMA is equal to 180 degree. Therefore angle PMA is equal to 180 upon 2, which is equal to 90 degree. This 2 will go on right hand side. Here it is multiplication. Here it will get divided by 180, that is 90 degree. Therefore angle PMA is equal to angle PMB is equal to 90 degree. So each angle is 90 degree. Therefore segment PM is perpendicular to segment AB. This is number 2nd. But from construction, M is the midpoint. Also by construction, segment AM is equal to segment MB. Now this is the perpendicular and M is the midpoint. Therefore segment PM is perpendicular bisector of segment AB, therefore point P, therefore point P lies on is on the perpendicular bisector of segment E. Hence we have proved the